Morning, I'm Stuart. McMurray. I am by day, lead offensive security engineer. By night, I'm a Unix nerd, ma'am. Okay. By day, I'm somebody who does not know how to use a microphone. Thank you. In the back, I'm audible now. Excellent. All right. Pretend I told a really cool joke.
If you want to increase the volume, just go in here.
Oh, thank you.
Yeah, you can. And that's for a computer there.
Oh, nice. Hopefully, it shouldn't make any noise. Yes, the joke. By day, I am a lead offensive security engineer. By night, I am a Unix nerd. We used to just call this a red teamer. Except tonight, I probably will be a Unix nerd with a cold, so apologies. Apologies for that. I have no idea what's going on social media these days, but that will probably work to get in contact with me. And I'm not associated with containers or Docker or anything. I'm just some random dude. Also, there is a sort of CTF-ish thing if you want to take what's in the talk and try it yourself. That works. Here, and it'll be on a couple slides, so feel free to grab that, drop it on a Debian box. It will kind of take over your Debian box. Use one you can get rid of, VM or something. Standard disclaimers, this is not my company. I'm talking for me. Don't commit crimes, etc. And if you do, I didn't tell you how. Anyways, for the next however long, we'll just talk about the general idea behind container compromise. We'll make a little dummy target. We'll talk how that works. Get some initial access real quick to it. And then we'll spend a little more time doing sort of inside the container things, like what's hacking looking like inside a container, and break out and do things from outside the container, eventually breaking back into a container. There'll be some other things in there, probably. So without further ado, what do we mean by compromising a container? If we were to look at this first question, what compromised? Well, if we take some sort of lockdown, something we're not meant to have access to, something that sounds like, hey, there's a conference room full of hackers. I would like them to not be able to touch this. And we take a conference room full of hackers and they do something, to access that box, to change its state, to read something they're not supposed to write something, whoever it was stopping us, well, didn't stop us. That is what we mean by compromise. There's no one sort of like, this is it. But take it what it's worth, which is cool. Now it's a container, and that's the next question. And we'll answer this in several steps. But for now, if we just ask an application developer, the sort of person who's writing the things that we are trying to hack into, he'll probably tell you a container, well, it's just one of those things. It's where my application runs all nice and self-contained. The circular definition. I promise a better definition later. For that, why would we compromise a container? And simple answer is nowadays, that's where things run. Is the cool hip buzzword. There's test-driven development, like you write your tests and then you write your code until the tests pass. I think it's a lot of resume-driven development nowadays. You write your resume and then you develop your system until it passes an interview. And that's actually why. That's because that's where our target space is. Speaking of target space, we will have a single server, and the server itself is not particularly important. It's Linux, because containers. It doesn't really matter. A conference room full of hackers, check. The server does not matter, but it does have a couple containers running. It has an HTTP checker process. It'll let us check if a website's up. It has a password store that consists of sort of a front-end thing where we can request passwords and a legacy database behind it. It'll be our target to break into. If we use Docker PS as one does, look at what is running, and it doesn't have to be Docker. This is not particularly Docker specific. We'll see, we have a password store container. It's listening only on localhost. So can't hit that from the network, but our HTTP checker is listening on all interfaces. It's sort of a admin DevOps utility server, I guess you could say. Initial compromise will be the HTTP checker, as that's what we have access to. Looks like this. It is a very sophisticated website. You stick in the right arrow button, stick in a URL, and it will tell you it worked, what the output is, what command it ran to get there. Very sort of like some manager asked, hey, how do I check if this website's up? And someone made him a GUI for it. But of course, we notice being enterprising hackers, there's a couple quotes. There's what we typed between the quotes, like, maybe this is injectable. So we'll try it. Simple little payload. And if it prints the working directory we're in, we win. And it does. That is what we stuck in. So you can see you kind of, closed a string, comment, or closed a string, next command, so on and so forth. Commented out. We have our output that's like, yes, we ran arbitrary commands. That's nice. We've compromised a container. Pretty simple, and it does happen in real life. All right, so at this point, let's stop and ask ourselves, again, what is this container thing we're talking about? We'll ask a sysadmin, the guy running this box. And the sysadmin is likely to say, well, it's just an application running on Linux. We saw Slash. It's probably Linux. Plus some isolation, plus like lots and lots of YAML. If you do anything with containers, yes. This would be a very short talk if there's not more to the story. Let's digress, talk about command and control, which we'll need to do things with our container. Sort of the idea is that we have a thing we want to do something with. We are sitting here, it's over there. We'd like to give it a command and exercise control over it. Many ways you can do this. There's good ones, bad ones, few helpful tips. Number one, it actually has to work, which sounds obvious, but there are many things that can get in the way. Firewalls, wrong platform, programming environments not installed, whatever have you. Number two, especially as an internal red teamer, don't be a jerk. Don't use too many system resources, leave things unencrypted. You get a lot farther if your C2 is solid. And more importantly than all of the above, simplicity is sort of the answer to C2. Simplicity both in the sense that it's easy to set up, just like a couple commands, it installs itself, but also simplicity in that you can keep each layer of whatever you're using in your head. That comes into play when you send reports to people and you're like, hey, I found a vulnerability, and they're like, prove it. And then you have this long talk about connecting backwards and forwards and things, talking to things, and it's like, the simpler it is, the better. Many ways you can do this, curl a lot in a loop, sometimes not in the loop. SSH works pretty well, or whatever management software, AWS, SSM, take your pick. There's loads and loads of frameworks out there that do some pretty cool things. I find that while they do a lot, I don't always need a lot. Simpler the better. If you're getting into programming, writing a little C2 thing is kind of a cool second or third or fourth project maybe. So TLDR, whatever you do so that your target does what you say. I'm giving a similar talk in Belfast, and there's a group of people out there after the talk asking questions, and there was a fellow in the back. He just kind of looked at me like expectantly, and a fellow sort of closer to me. He was like, hey, why do you have a blue moose on your slides? And I said, well, actually, a teal deer, TLDR, teal deer. And the fellow in the back just looked at me and he's like, oh. I think he probably went to bar. There's many people in here wishing they're doing the same. All right, so we've asked the HTTP checker to check our HTTP. It did sort of, we saw under the hood that just called a shell command. And we're like, oh, well, that's kind of cool. It's a shell. We like shells. We could maybe use curl. And curl is a program that makes HTTP requests, among many, many other things. We can just have curl connect back to our server on the internet or wherever appropriate, and we'll use that as our input to our C2 thingy, input to the shell, and we can make another connection back with another curl, and we'll hook that up to the shell's output, and there we go. So we just have now bidirectional comms, a couple TCP streams in a shell that's already there. Easy enough. The one hacker tool we'll be using is called curl rev shell. It is a reverse shell using curl. And very easy to set up. It looks a bit like this. Typical go install, nothing interesting there. It installs itself, run it. And it will just give you a one-liner in blue there to say, hey, put this on target. And it is in the interests of best DevOps practices, pipe to SH. So staying consistent with our target space. What you're piping to SH as really just if we look back here, a curl pipe to a shell, pipe to curl. Not much to it, and it works. So, sticking our shell injection, it does get injected. We're like, hey, do you get a shell? And there's a magical moment where you're like, gonna come back, gonna call me back. And sometimes it takes a couple minutes for things to spin up, and you're like, gonna call me back? It called us back. First couple things we run, we set our hist file environment variable to dev null. It is not likely something in a container is going to be logging shell history to a file. It's also not likely you're going to find an SSH server in a container, but that also happens, so you never know. And then we'll just, a typical situational awareness, processes who we are, where we are, etc. We're in a container, and often things are missing. So no PS in the container. That's kind of a problem. But we do see, hostname looks very containerish, running as root. It's pretty normal. Containers are like it works on my computer, and now it works on your computer. It worked on my computer. We'll run it as root. Another quick diversion. Okay, so as group of somebody who just got a shell, what is this container thing? Well, actually, it just looks like it's Linux missing some things, but just Linux under the hood. And that is sort of what it is, which is nice, but what does that actually mean for us? Before we answer that, let's make a quick side quest to proc. Proc is sort of the underlying things for all these, a lot of what we do. So we ask for a process listing, By the way, this is a great way to list processes in polite company, this PS, oh dear, if you need a mnemonic for it. But yeah, so we asked for PS, oh dear, see what's going on. Of course, we would have liked something like this, nice, like tree formatted thing, user ID or usernames, PIDs, all good stuff and work. We'll just use proc to get that. And what proc is, among other things, file system. It's just a mounted file system like the others. It's kind of a funny file system, though. It's not really actually files. A bunch of null bytes, or a bunch of 0-byte files there, sure. It's a kind of a window into the kernel with a file-like interface. We can just use your typical open, read, write, whatever, but ask the kernel questions like, hey, kernel, what is the command line you're running? Kernel's an ELF binary, has a command line. And we just read that from the command line file. It also will give us info about processes running. Each process has its own directory named after the PID, and exe is a symlink to the running file. Com is the name of the process, which is not the same necessarily. Devices, we can see the partitions, disk partitions that are there, network things. Oftentimes it's not formatted in a particularly nice way, but unhexed is fine. Information about the kernel has all sorts of good stuff that you need once in a blue moon. And so if we were to run PS, if that actually worked, we would have issued PS, oh dear, the shell would have broken that out, run it, and PS would have just a bunch of reads of a bunch of different files in proc, ask the kernel, hey, can you read this file for me? The kernel would be like, yeah, sure, this file contains binsh, whatever, and we got our nice process listing back, which we did not. We can instead just ask for things from proc ourselves. So like we ask to ls proc.exe to get the symlink. Else will ask the kernel for read links. Read link system call. Kernel will go back and say, yeah, it's user bin, whatever, and tell us. ls. And then it looks like that. So there is a container hacking process listing. We will do better later. But a super simple way when you're there and you're not sure what it is. Proc has a bunch of other interesting files. These are the ones that, as I was putting the slides together, just came to mind first. They're handy. Pictures. There we go. So TLDR, this proc thing, our side quest, it's a bunch of systemsy files that gives good information. In case anybody else taking pictures, yeah. This is the one slide everybody is like pictures. And as I'm looking, like next set of the audience, oh yeah, I should. All right, so side quest complete, which would really mean is what we're actually going to answer with proc. We are inside a container. Right? So what does this mean? Well, let's look at it from an inside the container perspective. Where are we? We asked this. PS, of course, did not work. We will ask this inside the container style PS. And we'll just read all of proc star. So everything proc star command line. We'll read that. We'll print out the file name just for ease of visibility. And then a lot of things in proc are null byte separated. C style strings. There's just strings for string, null, string for string, null. So we'll just turn those into new lines because it's easier to see. I printed out the uname and AID that we wanted originally. And it looks like this. There's the proc1 command line for the echo here. And we see proc1 has 3 arguments. Fun fact, Windows EDR gives you a string, because Windows gives you a string. And I've been told that Linux EDR just gives you a string. So you do some fun things with that. Exercise for later. Anyways, proc1 is Docker init, so definitely in a container. There's the rest of the process. This is us, by the way. There's the curl shell that we've been using. Also, proc self is the symlink to your own process. So in this case, the shell is doing things. Uname ID, so on and so forth. And there's sort of our first blood, I guess, or our first thing to steal. Some creds we found. It's entirely likely whoever was using this actually templated the cred in the proper place and followed security procedures and so on. And 6 layers of abstraction later, it turned to command line arguments. It happens. Be nice to devs. They don't often know what arg is, but cool for us. Got a secret password. A little easier to see there. A better practice is, in some people's opinion, using the environment pass credentials instead of argv, which is cool, except proc PID environs. Proc PID command line works almost exactly the graphically. We'll sort it lexicographically. It's really nice for AWS because all your AWS things like at top. And it looks like this. And then we're like, oh, well, we also found an internal service password. So a fairly easy way to steal things. And one of the nice things about the container world is sometimes you don't really care what else is on the box. You're like, well, I got my container. I have my creds I wanted to move laterally. Life is good. And sometimes this is the first few minutes and that's it. But that would be a very short talk. So we'll do that. You can also pass credentials via files. proc mounts has the list of mounted file systems. Saw that earlier, and oftentimes there will be just a file mounted somewhere. See hosts frequently, but other things. This is resolve.conf. There we go, another one. And we can grab, run secrets API key and get some sort of secret API key as well. Okay, so what we were actually going to ask is what inside means, and really we've seen now some value of we are just a couple processes, curl, shell, curl. And we're processes that have just some other restrictions relative to the other processes on target. These restrictions come in the form of namespaces. What a namespace really is sort of some metadata tag, if you will, that the kernel keeps for you. Just a number. There's a bunch of them that are restrictive that the kernel uses to give you a different view of the world. Mount is one. So if you're in a mount namespace, which really means the process that is doing things like listing files has this particular tag set or this particular number, you will see a different idea of what slash is. It's hierarchical, by the way. So your children processes, sometimes your sibling processes too. Proc PID root is the root of your namespace. You can just look in some container's namespace. It works pretty good. Root in there or whatever. The PID namespace. We noticed that our container only has a handful of PIDs, 6 PIDs in there. PID namespace limits the number of processes you see and renumbers them. So there is always a 1 Docker init or something. Also hierarchical user, same thing. In the interest of time, won't talk about it, but suffice it to say 2 zeros is quite nice and means that what we see as root, the rest of the box sees as root. Net is not so hierarchical. And with net namespace, you cannot see into your parent-child containers or processes network namespace. So it makes dumping network traffic kind of interesting. We'll see that later. Handy way to see if you're in a restricted net namespace is look for iflink or ifindex and iflink. And if they're not the same number, you have a veth pair. So it's something that inside the container looks like a normal Ethernet device. Outside is virtual pair. It's also capabilities. Proc self status is a great thing to look at. And you'll see that in the effective capabilities, it's a bit mask. So if you have a bunch of Fs, if it's good, you have all the capabilities, capsh groups. Capsh will decode that for you. Also mentioned for no new proofs. 0 is good. 1 is not so great. C groups, SecOp app armor rules are not as photogenic. C groups kind of bind a process together. This is a group of processes that have this set of restrictions on CPU usage and such. Also, they all die together. SecOp app armor rules are a very, very roughly something like a firewall for system calls, very roughly. And then TLDR, escaping the container really is just a process with a normal set of all of these. A process that has the mount PID namespace of real init or non-container init, so on and so forth. Quick aside, you hear about privileged containers, like don't use privileged containers usually in that context. And Docker themselves will be like, if you don't have to, please don't. Here's all the things it adds. A privileged container. Docker is also like, maybe you shouldn't do this if you don't have to. It's sort of the modern chmod 777 in sudo. You get some young knuckleheads like, oh, I don't know, netcat didn't work, so I just ran it. I sudoed it and it worked. I don't know why. So now it's like, my container didn't work and I ran it privileged and now it works. I don't know why. And it's quite nice for the rest of us anyways. Cool. So the question we've been answering, what is a container? Let us ask a group of conference attendees who are fixing to escape this container. What is a container? And it's just another Linux process. Just have metadata, but it is a Linux process like any other. How does escape then? So there's 2 techniques, and we'll put the slides together. I just Googled, how do I escape a container? And the first thing that shows up is a mounted socket, and it works sort of. It usually just gives you a privileged container. We have one of those. It is good for lateral movement. If you have Kubernetes socket mounted, you're like, I would like a privileged container over there on a box where there's a cohabiting container that I want. It's quite nice, but it's just a privileged container. We have one of those. The other half of the search results on the first page of Google were cgroups release agent. It works for cgroups v1, and I have never got this work in real life. I'm sure it did at one point, but never mind. Another thing that works pretty good, mounting a partition. So we are real root. We can say, hey, give me all the partitions of the box. You get the major minor number. You can make a device file, mount it, root into it, etc. And then you can just add something to cron tab or add an SSH key outside the container, whatever. You're not properly escaped. You don't have a new process, but you add an SSH and SSH in, it's good enough. Actually, we'll use procsys kernel core pattern. And that is, it makes a smaller system change. It doesn't modify the system quite so much. If you modify cron tab, it runs every minute and you have like this minute of, am I going to be cut? Is this going to break things? Avoid that. It's also my experience anyway. It's a little easier to not break things. But really anything. If you can get out, you can get out. Every CTF now is going to have some sort of container escape, some strange contrived situation. But yeah, TLDR, we just need something inside a container that will make a process outside, a process without the restricted metadata. Theory behind proc's kernel core pattern is if a program crashes just right, and that means it gets some sort of signal that does this, SIG-SEG-V is one of them, it will create a core dump. Well, really, the kernel creates the core dump, which is just a file with some debug information, and the kernel will look in this file, proc's kernel core pattern, and file it. Some proc, sort of like a file that lets us set a setting in the kernel. For the pattern, for how to write the file name. If there's a %p in the pattern, it'll use the crash process's PID. So core.%p turns into core.103, something along those lines. But that means we have some level of control over what the kernel's doing, even inside the container. Also, if the pattern starts with a pipe character, instead of just writing a file, the kernel calls a program that is the rest of that, splits it on spaces into argv. It calls it as root, calls it as a child of thread D, which is PID2. It's very much not a container thing, the kernel thread name, but importanter, the restricted metadata is not so restrictive. And we get nice command execution. TLDR, we will take an outside container process, or make an outside container process using the crashy core dump handler. In real life, it looks a bit like this. We'll just write a script in our container core handler, the bash script, and we'll just set our standard out and standard error to a file named whatever our script is going to be called, the core handler. And with that, because outside the container, it's going to have a different name. It's not going to be /core handler, but whatever. We'll write it to whatever we are, .out, send standard error there, so we can then see the output of whatever else is running in the script. So process listing, and hopefully PSODIR actually works this time. If it's not in a container, it should. Make sure it works, give it execute permission, so on and so forth. That all worked nicely. We will sleep. We'll run a sleep for a while, so it's easy to search for in a process listing. A nice greppable sleep. Looks like that's going. A core pattern originally was core on Debian, distro specific. We'll change that to pipe proc %p root. Remember, proc PID root is the root of a process's file system. Root of process's mount namespace. So that %p is going to be our crashed process. So inside our container, /core handler, the file we made, that is that core handler. Excuse me. Looks good. And then we need something crashed, so we'll just run another shell, and we'll have the shell send itself a $, PID of the calling process. Or excuse me, PID of the calling shell. It crashed, core dumped. And we see we do have the core handler.out container, or core handler.out file, which is right there. The one we made. If we look at that, we grep for our PSODIR, we see that, we have our shell script up in the kernel thread section that you kind of scroll past when you're looking at a process tree. That is the kernel threads, and there's our script, yes. And that is init, well, it used to be init, now it's T. Sure. Scroll down a bit, grep for the sleep, and this is our container. It's just more Linux process. There's our crashed shell, which will live as long as the core dump handler lives. That's cool. I would rather shell than running commands one after another and modifying a script. We'll more or less the same thing, except we will, instead of execing output standard out, standard error to a file, we'll use exec to set argv0. So there's a difference between argv0, process name, process binary, so on and so forth. Argv0 is going to show up, though, in here's what he ran. EDR, again, no naming names, whatever, but it's like, this is what the command was. Very, very definitively incorrect. And we'll just name it something that looks like a kernel thread, something completely benign, not malware. And have that call our curl pipe to sh from curl rev shell earlier. Looks good. Sleep so we can find it. Everything looks happy. Self-sacrificial shell, seg faulted, so on and so forth. Finally putting the core pattern file back. If you do not, you might wake up the next day to several shells. Haven't done that. Cut our callback. PS works this time nicely, which is good. There's the thread D of which we are a child. Down here, no reason it had to be shell, pipe to shell, or shell, child of shell, child of shell. You can do it much more gracefully. It's just easier this way. And now we have a script container. So we are out. That's from the exec -a there. There we go. Scrolling down, this is the entirety of our container. So we have container D shimrun C, which is the child, or the parent of it all. Docker init was what we saw, like way the heck back when, 10 minutes ago, when we were like existing processes container style. And there's the shell that's the curl pipe to shell, which then spawns another curl pipe to shell, pipe to curl. So there's our container and our sleeve that we were looking for. So what we did, then now we just have a normal shell via a core dump handler. It's a nice little escape, and it works pretty good when it works. All right, so back to this question, this persistent question. What is a container? Version 5, as a group of people who now have escaped a container really is just another chunk of a process tree with slightly different answers from the kernel. Kind of the same thing as restrictive metadata, but restrictive, different, whatever. It's just a chunk of process tree. Okay, so we're out of a container. That's nice and all. What do we do with this? Because if the box we've just escaped on is running containers, probably all the good stuff is happening in a container. And our original goal, way back when, was this password store, the front end thing with a strange legacy database. Now that we're out, we can do things like search for it. And we see that for reasons which are totally obvious, the database is written in Forth. Sure, as the process does the front end HTTP thing. Graphically, there's that Forth database. If we list the root directory of 2.5, which is our database, else is just like, yeah, it's a symlink. It points to the root of the file system. And we're like, yeah, sure. Let's look for the Forth files, passwords.fs, whatever, and the root of the file system. And it's not quite there. But we can CD into the symlink. And then suddenly, if we ask the files, it's there. It's a weird one, as things in proc are. So if at first you don't succeed, you're in proc. You could try and run it. You should not usually just run random things on target. Like, oh, it's on the process listing. I'll run it. That can have unintended side effects. But it didn't in this case because Forth on most Linux boxes is not there in a container. Sure, we're not actually in the container. We can get the file anyways. We can grab that. We have exfilled super sensitive IP. So we're back in the process, so the current work directory of our Forth process. Let's just chroot in there. Typical chroot, like, yay, TTY is not working. We can run a process listing, or could, but now we're chrooted into a container, so our root of our mount namespace is now the container root-ish. We do see that the Forth files are there, sure. We try and run it. Forth is there now, because it's sort of in our path. It's where you expect it, finally. Of course, passwords.fs is not there. Whoops, get out of our root, but it is a useful way to find things, and it's especially useful if you're running AWS CLI, kube control, something like that, where files are sort of expected to be in different places. Sometimes that is really all you need, which is cool. We actually like to sniff the traffic, figure out how these things work, grab a password live. If we list the file descriptors, procpid.ft is a list of open files for any process. List the file descriptors. We'll see for our backend, our 5, our Forth databasey thing, we have a couple sockets, but we also have password store.fs, which is kind of neat. It's a deleted file. And you can just totally grab procpid.ft4, and the file is yours. It's deleted. But we have these sockets, standard out, standard error, or connected, or standard in, standard out. So here, connected sockets. It's a little interesting. If we look at the front end thing, we're like, oh, there's a socket with a suspiciously similar number. We look at the TCP connections inside for this process's net namespace, not ours. If you just net stat, it wouldn't work. But yeah, for this process's net namespace, look at the TCP connections. We're like, oh, there's kind of like Unix chiasmus going on. These are probably talking to each other. It's hexed backwards, but yeah, close enough talking. Okay, let us look at the inode numbers. Yep, they line up. All right, we can probably just sniff traffic and figure out how these things are talking and not have to pick apart Forth. Entering a container theory. And I've been asked many times, why not just use Docker exec? And the answer is, then I have to figure out if Docker's on the box, which is not guaranteed, and that is a known trick. It's a bad guy technique, so I don't want to use it. The theory behind what we're doing is network namespaces are not hierarchical. We can't just list files like we did procpid root. And it gives some people a false sense of security. You're like, oh, network inside a container, that's visible, right? And as I mentioned, there are files that sometimes you really do just need to be in the container and it'll all work. Python dependencies, forgot to mention that, another terrible one. But as we talked about, processes with funny namespaces and other things. Namespaces are what gives us our view of network. We don't want to lose our capabilities or switch C groups or whatever. We just want the network namespace. So we'll just mooch it. We'll just grab one of the processes and grab the network namespace from that in the container, whatever a container is for us today. There is our container again. If we list the network namespaces of ourselves, self, and the front-endy thing, we get two different numbers, as you would expect. Mount namespaces, similar, 2 different numbers, 2 different namespaces, 2 different views of the network and the file system. TCP dump we have outside. This is installed on the normal outside the box, the host. Why, I don't know, but it's there because it would be a very boring demo if it weren't. And we'll use NSEnter. And NSEnter, netspace enter. It's not specific to containers, it just will enter a namespace, and we'll enter a namespace from this 4th process. And just the network namespace. You can enter all of them if you want. But we really want the network namespace and not the mount namespace because we kind of would like TCP dump. We see we're running. It spawns shell. So NSEnter, our shell spawned NSEnter, NSEnter exects itself into a shell, and so on. And we see now that, yes, our network namespace is the right one. And we still have our right mount namespace. We'll still have TCP dump, but now TCP dump can see inside the container. We run it. Like this, couple interesting things. We're listening in loopback, and loopback is, I believe, per network namespace loopback. So this is not the loopback that you would normally see if you just SSH'd in. Also, we're only going to grab 3 packets. If you have a shell like this, Control-C is not really a good idea. It's not really a good idea. So limiting the number of packets you capture means you don't have to go re-exploit. Anyways, we see it. It works. We see a packet coming to us, and it's like, oh, somebody's LDAP username. That's quite nice. We see the password coming back. That is good. And we finally, 31 and a half minutes in, have got our password. TLDR, entering a container then is really just having the right namespaces. Last iteration is a container. Yes. Depending on what layer of abstraction you're working at, yes, it is. And really, do you care? Not really. Quick summary. So, hacking containers, it is not terribly much different from using Linux. You just use proc a little more and make some strange processes. And the containers themselves, they're just groups of other Linux processes with some metadata. And the escaping part is just less restricted processes. By the way, the CTF thingy, if you would like to retrace these steps, you can grab that there. So, my God, we even have time for questions. Amazing. Thank you for watching. Any questions? Yes. I don't have an answer because A, I'm not going to say yes. And then what's going to happen to somebody over there is going to be like, well, actually, nobody in particular is that direction. I think you would be surprised that it will get past most EDRs, but I don't have the breadth of experience testing it on everything possible to really answer the question, but let me know. Question? Also, this is my coworker and a complete jerk. Jump behind him.
What do you suggest if you land a container as a half-pro, like since the beginning?
That's where it gets fun. Then you can upload your own curl if you can find something. Some shells, depending on what shell you have, will just make a TCP connection for you. Dev TCP, which is not really in dev, it's a shell thing. Of course, then you're not encrypted. You can use OpenSSL if they're there to make a network connection. Pretty much anything that will make a TCP or whatever network connection, anything that gets byte to and from, preferably with some encryption and not using, spiking the processor or whatever else. It doesn't really matter too much as long as it works. You can do C2 over Git, like it works. Yeah, so very situationally dependent. Good question. Yes. Caused a host to crash. Well, you never really know. Boy, is this a non-answer. You never really know because, it's all remote and you shouldn't have access to the back end. I've caused certain things on hosts to crash. I've caused some DOSs of larger systems. I don't know about a specific host inside, from container escapes. It's a good question. If I think of it while other questions are answering, I'll let you know. Are we being recorded? Anyways, any other questions? Yes, person I definitely don't know and I'm not married to.
Can you go back to the slide where you list the definitions of what a container is, please?
So the backstory to this question is I've given this talk before in Belfast, and I have 276 slides. And somebody in the audience, I also definitely am not married to, asked a very similar question, knowing I have a lot of slides, and I just kind of held the left button a lot. Yes, I can. I have a different slide deck. What slide did you want, or does it even matter?
It was the very last one, all the definitions.
Oh, right, yeah.
Well, I wanted one that was really
Pardon me? Yes, sir, I can. Look, it's actually quite, I mean, sort of, maybe. Was there actually a V1 that I just... There's like tough crowds that are like, your jokes suck. I live in Berlin, right? And telling jokes to Germans is not guaranteed. This is the opposite of that. Yes, we can go back to one for you. Any other good questions? Yes.
Much benefit for other platforms like AWS Fargate that gives a more restricted container rather than server running.
Question was, do I see a benefit in a platform like AWS Fargate that gives more restricted containers? I mean, that's definitely not a benefit to me. It is a benefit to somebody, though. Under the hood, though, they tend to, I mean, if it's containers, unless they're super different, it's Linux, you know. There's a t-shirt, like, my other computer is your Linux box, or the cloud is just Linux, yeah. I can say some of the stranger runtimes have been problematic for me. Like, core pattern there's one, and I couldn't tell you which one it is. Like, it says core pattern is mounted, and then it's actually fuse mounted, and it's not really core pattern. So yes, the actual answer is yes. It can be, but situationally dependent. You know, also extra complexity, costs, so on and so forth. So, it's a good question. Question was, what about exploiting a kernel? I have not thrown a kernel exploit probably in a decade. I avoid them because they are often somewhat unstable. And that will oops the box sometimes. Which actually might have been the last way I oopsed a kernel. Yeah, no, I mean, when they work, they work. I would much rather spend the extra time and effort finding creds, finding another path. Yeah. I in my experience, no, but I have a very limited experience compared to the rest of the world. I think, you know, I'm just one dude. Nowadays, though, things are patched very much more quickly. Oh, unit warning. Yeah, things are patched a lot quicker nowadays. So it's also less likely you'll find something. Yeah, no, it's a good question. All right, and we have 2 minutes worth of question. Minute and a half worth of question. Minute and 15. Does the kernel have, will the kernel tell me which container runtime it's running? Yes, but you have to ask the kernel's executive assistant, usually like a lieutenant. You say, LT is running. All right, that was not a good joke. Sort of. So, I mean, the kernel will list your processes, and sometimes those will tell you. So, very technically, yes. But, I mean, maybe if you looked at a kernel version and it's like Amazon Linux, Kubernetes, maybe. But I mean, once you hit under the hood, you kind of don't care that much. Yeah. So, not that comes to mind, but it is a good question. It's a good thought. Yeah. All right. Are we 1 minute? 1 minute. No.
Go back to the
No.
proc slide.
You mean the one where I was like, okay, people take pictures. I was like, okay, we're going to flip the slides. I see them like, oh, wait.
I don't need it. I just wanted to see you slip.
Do we have any gentlemen from South America? This really is a Juan question. And my wife's not from South America. Sir, are you Senator Juan? Is your name Juan? No. Oh, well, anyways. Go on then. What can I do for you? Thank you. I appreciate that. What am I looking for?